Hi everyone, my name is Giray, and in this experiment I will demonstrate how to determine the electrical resistivity of a wire using basic measurements of voltage, current and geometry. The main aim of this experiment is to understand how the resistance of a conductor changes with its length and cross-sectional area, and to calculate the intrinsic property of the material, which is resistivity ρ. Resistivity is a material-dependent quantity that does not change with the shape or the size of the wire. However, the resistance does not change, and it's directly related to the geometry of the conductor through the equation, as you see in down. Here, L represents the length of the wire, and A is the cross-sectional area, and ρ is the resistivity that we want to determine. By measuring the resistance for different wire lengths and keeping the diameter constant, we can observe this linear relationship and extract the resistivity from the slope of the graph. In this experiment, I use a nichrome wire. First, I measure the diameter using a caliper and calculate the cross-sectional area. Then, I set up the circuit with a DC power supply and multimeter. For each wire length, I applied a constant voltage of 5 volts and recorded the current flowing through the wire. Using Ohm's law, you can see in the down, I calculate the resistance for every length. After collecting all the data, I plot the resistance against the geometrical factor L divided by cross-sectional area. The plot showed a clear linear trend which supports the theoretical model. From the best fit line, the slope corresponded to the experimental resistivity of the nichrome wire. My experimental result was approximately this, and which is quite close to the theoretical value of nichrome wire. The small difference between the two values likely comes from the sources of the error, such as temperature increasing in the wire during measurements, small uncertainties in current or voltage readings, and the internal resistance of connecting cables. Overall, this experiment helped demonstrate that the resistance depends on geometry, while resistivity is a fundamental property of the material. It also showed how experimental data and the theoretical models can combine to determine physical constants with good accuracy.